So today I'm going to talk about successfully reducing Firestore read operations. And as it's the last talk for today, it's kind of an unfortunate position here, but let's try to make the best out of it. And it's probably not like standard. All right, it's also called The Creation of Software, Part 1, a project's genesis. So Genesis, you know that from the Bible probably. It's about how things began. And I want to tell you now, like in the first place, it's about Firestore, it's about Firebase, how Firebase was created and how they started up. In the beginning, James Templin and Andrew Lee created Evolve, a real-time chat API in 2010. They said, let there be fire, and Firebase evolved from Evolve, 2011. They said, let there be money, and Firebase raised 1.1 million in seed funding in 2012. And they said, let products sprout, and there was Firebase hosting, and there was Firebase authentication in 2014. Then Google said, let's acquire Firebase. And Firebase was acquired, late 2014. And to every beast on the earth, and to every bird in the heavens, and to everything that creeps on earth, Google gave Firestore in 2017. And behold, it was very good. Thanks. So, but we are not finished yet. These are the generations of software and data when no line of code was yet written and no dog had yet sprung up. For you, the developer, had not caused it to be created in the database. And there was no user to use your app. So you planted your code out of the ground. You made it spring the data. A stream flowed out of the Firestore to expose data to the app, and it was used in 4 different streams. Then there was a second and a third stream, all real time. Then you received your first users, and you told them you may surely consume every stream in this app. And of course, your first users were naked and not ashamed. Well, something went wrong. Now a queue came up of users that wanted to use your app, and longer it became, and they all used your streams, and they all read your data, and your Firestore reads started rocketing from Earth into the heavens. Okay, that's the end of the first part. Okay, and that's what's usually going on if you are starting up, implementing Firestore into your app, and then a few users come onto the platform. This is like a very common issue a lot of people have. My Firestore reads counts are in the millions. What's going on here? So let's dig into that. And the purpose of this talk is to give you some tools, some handy tools to first identify where those read operations come from, if it's even real operations. And yeah, so that's where we start part 2 now. It's called the boring part. So we could also try something, because I thought it would be funny to say, to pick like 5 people from you, from the audience, volunteers ideally, who always shout boring whenever I say reads. Could try that. Any volunteers? 1, 2, 3. And I picked like some random people from back there. So let's try that. Okay. I talked about the session goals. First, we have to understand how Firestore, how the pricing actually works. Then we are going into cost drivers, see where cost can come from, and we will be able to monitor the reads and be it's very good. And be alerted on read spikes. Wrong. It's read. Apply patterns to reduce reads by design. All right. So the most important thing you have to know is when it comes to billing, it's built by document read. So if you want to get like the oldest 20 sheets from your database, that looks like that, then although the collection contains 4,000 elements, it only generates 20 reads. The same applies to the snapshot listener, the real-time listeners I was talking in the beginning about. But here, in addition to the 20 initial reads, you also get one additional read per document change. So let's try this. You have like a lot of sheeps, and you want to get like the one black sheep. So this is, of course, possible like that. It's a filter. And also here, the same applies. You only get one read. So what does count as a read? What did we just hear? One read per document when it's about a query, and one read per document and one read per document change if it's a snapshot listener. And part 2. And part of the boring part. So no boring shouts anymore, please. Interlude. Meanwhile, in your app, the tower of read operations. Now the whole earth had one app and the same streams. And as the user base grew, you started to build more and more widgets. And the reads reached to their high tops in the heavens like a tower. And you came down to see the widgets and the tower of reads, which children of the widgets had built. It's yet another boring part, and it's called, and you came down to see the widgets and the tower of reads. So we will try to identify now where those costs come from in the first place, and I will show you how to work with the Google Cloud Billing Console. So this is basically how a standard billing thing looks like when you start your project. You have different like technologies from Google, and it's very well distributed, as you can see. App Engine is like a very small part of it. Now in the scale-up scenario, where, for example, my company is in, it more or less looks like that. So you have the App Engine part is way bigger now. And now you might ask yourself, what is App Engine anyway? Well, I can recommend you to group by SKU. And then you can see it looks like that. The App Engine part more or less corresponds very much with the Cloud Firestore read operations, as you can see. And so we now know, okay, our problem are actually Firestore read operations. So we have to dig into that. So that's why the purpose of this talk is, of course, to fix that. But first thing, always go there or tell your CFO, whatever, whoever does that, to look into Google Cloud Billing to identify actually where the costs come from. That's pretty well documented there. What you can also do is to set up alerts to say, okay, I want to spend only 80 euros a month, and whenever it surpasses 50% of that, you get alerted. So when something goes wrong, at least at 50%, you get alerted. But the most cool thing actually in the Google Cloud Console is that you have the Google Cloud Monitoring, and there you can build custom dashboards for nearly everything. And so what you can do there is to set up reads, alerts for read spikes, for example. So if reads go up very quickly, you can monitor your cloud functions if you use them, and multiple things. So here is an example of parts of a monitoring dashboard. On the left side, you can see a alert, how it's created. So it's actually not like you don't have to write all this code to create an alert, right? But here's something you can really document it better if it's in code. So I downloaded the code. And this more or less corresponds to the right side, although there are 800 reads as alert set. On the left side, it's 200 reads, but it's more or less the same. And then it looks like that. And whenever it surpasses this red line, you can be notified in the Google Cloud app or in Slack or whatever. So that's also super useful. And what I did in the top is that I overlay, I made an overlay of my Google Cloud Functions version 1 instances with the read operations, so that I can see if there are potential overlaps between a function being triggered multiple times and special read operations. And at the bottom, I basically said, give me all the reads, the max reads, or the sum of reads in this case, but give me also the same line from yesterday. This is the dotted line, so that I can see, okay, it's a recurring pattern actually, and it's probably a scheduler, or if it's really like, in this case, it's you don't see any matches, so it's probably simply user behavior, or it's coming from the client. And we also saw it's about the actual yielded documents. This is something that counts as a read. And so this here documents a bit an inefficiency, for example, because you have the scanned documents and you also have this yielded documents, and they are more or less have the same count. So if we think about the sheep's collection from before, it could be, okay, it scans like 4,000 documents, but it only yields the first 20. So this should differ. Here you can also see if there are differences or inefficiencies when querying. Should wrap up. So you can go to your Google Cloud Billing to find your Firestore reads by grouping as SKU. And you can also set in the Google Cloud Billing console alerts so that you are notified very early about things going wrong. And the same you can do in the Google monitoring dashboards, also set alerts on actual thresholds. And like just simply have an overview of what's going on in your system. All right. So now there's another part. What it's about, like a little interlude again. Meanwhile, reads flooding the bill. While your bill grows, you remember that you once heard about read optimization in Firestore. This Lord said to you, dive into code, you and all your household. Take all your tooling and prepare it for the great read flood that is coming to your app. And the reads rose upon the app 40 days and 40 nights. Then you use your billing tool to identify costs and drivers. Still, reads did not cease. You remembered him talking about audit logs as well and created your final tool. In the second month, on the 27th day of the month, the reads suddenly stopped rising and started dropping. So that's another super important, cool thing you can do. You have audit logs in the Google Cloud Console. You can activate them by going to IAM admin, audit logs, and then activate them for a service that you actually want to log. And really do it carefully because it logs a lot. So it will really spam all the other logs, but it gives you important insight. So an audit log in general looks like that. It has a timestamp. And it has some payload information, for example, which method name was done. Here you can see it's either it's a query or it's a snapshot listener and some additional information. So let's check what method names there are and what that actually means. So the method names can be listen, run query, batch get, and you basically see what it means. And you can then, again, group them or whatever, count them or whatever, and see, okay, I have a problem with real-time listeners in my app because nearly 80% of all audit logs are real-time subscriptions and so on. So that's an important part you can do. That's an important information you can gather from those audit logs. And this is how you can then extract the collection ID from those audit logs as well. So this is also part of the information you get there. And it's different for each of those, how was it called? Operation types. So for the run query, it looks like that. It's in the structured query request part. And for the listen operations, it's in an add target part in the query. And so that's, yeah, we only want to get the read operation. So for us, that's enough. And what you can also get client information. Is it a front end? Is it my app? Is it a web client? Or is it my backend that's actually triggering those things? And you can like experiment with it in the logging overview in the log explorer in the Google Cloud Console. This would be a search term you could use, for example. But more powerful it gets if you kind of write a script that analyzes that for you. And that's what I did. I wrote a script, or actually AI did it for me, but I gave it the audit logs and told it to extract all the collections for me, count them, and give me an overview in the end of which collections at which time from which client were generated. So yeah, this is how the thing looks like. The Python script in the end, it's what I just said, basically. So you can see the structure and how it's accessed, how the audit log structure is accessed here. And here it's accumulated to count it, and then in the end prepared. And then you get like this kind of thing, this output, and then you really know, okay, in the last 2 hours, for example, I had real high reads for users. And then you can dig into that. You see it's coming from my app. Okay, real-time listener, I have to pay attention to that and optimize my code here. The Sermon of the Mount. After fixing the problems in your system, you opened your mouth and you told your learnings, saying, "Blessed are the limited queries, for theirs is the kingdom of thrift. Blessed are those who filter, for they will be efficient. Blessed are the CFOs, for they keep track of expenses. Blessed are those who hunger and thirst for observation and dashboards, for they shall be satisfied. Blessed are the audit logging devs, for they shall receive clarity. And blessed are the ones coding efficiently by design, for they shall see less reads. Rejoice and be glad, for your app is great in efficiency now, for so your bill will stay small." So let's go into the last part, which is like, how can we reduce reads by design? So now we spend some time finding those inefficiencies. How can we prevent it? Okay, some very basic things actually, and some things which we also saw on the slides already. Always limit your queries. So whenever, because only reads count that are really like the result in the result. So always limit it if you are only interested in a subset of those. And important one is also whenever you use the Google Cloud or the Firestore UI, also limit your queries there because it's the same. So it's another client, simply another client. And if you search for like through the whole collection, it's probably not what you want. And use pagination. If you have lists of 200, Flutter can probably handle that very well, but still the user might not use all the 200 documents you downloaded, but you can give it in little chunks of 20 elements. And then you can do it like this. You have your base query, you get the first page, and from the first, and this is like the base query for the first 20 elements. And then from there on, you can say, okay, and the next one, the next page I want to get starts actually at the last doc of my first base query. And so you can continue building up pages with these so-called query cursors in Firestore. Of course, filter not locally, but filter in your query directly. Also, I mean, it's very obvious to do that, but I've seen people doing it differently, so something to remember at least. If you think about the first example, in this case, it would have counted 4,000 documents in the first example, and then you filter locally for getting one. And in the second case, it only counts one. And if you really want to have real-time streams in your app, you could also say we combine the things. You get like the first 20 elements as a stream and the rest as classic non-live, non-real-time documents. And then you could use, for example, a block or whatever pattern to combine this data. Yeah, okay, enable offline caching persistence. That's usually done for iOS and Android clients by default. But if you are using a Flutter, if you have a Flutter web project, for example, you have to explicitly enable that. So whenever you are not online, your app is still usable, and only things that have changed in between will then be synced afterwards. And if you want to take it a bit further, of course, it's a good idea to use a local database like Hive, CE, or whatever you are preferring. And then you have the whole, like you're in full control when you really want to refresh your data. Although this also makes things a bit more complex because caching is a complex topic. And whenever you go into a screen, listeners are restarted, right? So it's also super important to keep that in mind. When you are not limiting your real-time listeners, they will get triggered over and over. And in the first place, they always get all the documents. So there it also makes sense to solve this from an architecture perspective point of view to say, okay, I have this kind of this logic for getting the data somewhere in a repository or wherever. And the last thing is, if you can, prefer writes to reads. So here's the example of a statistics table. For example, in our case, we want to give some statistics about the usage of some products to our customers. And instead of getting this whenever a customer accesses this function, I write a statistics collection whenever data changes. And so I can always, like this, these are actually write operations. So I write to this collection and keep data up to date instead of getting once the data from all different collections. And yes, so that's like kind of also a mindset thing. Okay, this last slide. The happy ending and the birth of Genesis. You solved your read issues and were live and stably operating end 2025. You said, let there be fire, and you and your business partner founded Genesis 2026. You said, let there be money, and Genesis raised 1.1 million in seed funding. What a coincidence. 2027. And you said, let the product sprout, and a whole SaaS ecosystem emerged in 2028. And then Google said, let's acquire Genesis, and Genesis was acquired in the late 2028. And to every beast on the earth, and to every bird in the heavens, and to everything that creeps on the earth, Google gave Genesis as part of their ecosystem in 2029. And behold, it was very good. Thank you.